Hello, this is Lilia Learns, and today we're going to be learning about isotopes, radioisotopes, and atomic mass. This video is to try to help grade 11 students to understand the topic. If you want to just understand the topic in general because you're curious, that's okay too. Okay, let's dive a little deeper into this. The mass of atoms is expressed in atomic mass units, or just U, the lowercase u. All atoms are based upon carbon-12. Therefore, the mass of an atom of carbon-12 equals 12U. 1U is 1/12th mass of one atom of carbon-12. Isotopes. Atoms of the same element have the same number of protons but different neutrons, which equal to different masses. I did write this in quickly because I made a mistake. It didn't make sense in my head when I read it over. But yeah, I just wrote the different neutrons in brackets. So you gotta remember, isotopes have the same number of protons, just different neutrons, which accumulates different masses. Isotopic abundance is the percentage of an isotope in the sample of an element. Radiation and radioisotopes. Some isotopes are unstable. They can spontaneously break down or decay, which give off a nuclear radiation. They are, aka, radioactive. Isotopes that decay to produce radiation are called radioisotopes. So if you ever see radioisotopes, you know they produced radiation and were unstable. Some examples of radioisotopes are americunium-24, which are in smoke detectors, and technetium-99, which is diagnosing/observing medical conditions. There are plenty out there, but these are the two examples I picked today. The causes of isotopes being radioactive. If the neutron to proton ratio is 1.5 to 1 or greater, it's unstable. So if I had a ratio of 1.7 to 1, that is unstable. But if I had 1.2 to 1, that is stable. Atomic mass. Atomic mass is the weighted average of masses of all naturally occurring isotopes in an element. So basically, if I had isotopes of carbon-12, which had 92.5%, and carbon-13, which had the rest of the percentage. I can't do math on the spot, yes, I know. But you would take those averages. We typically go with in a sample out of 100 grams, and then you would kind of do the calculations there. The 12 and 13, say the 12 in carbon-12 means it's 12 is the mass, so 12U. And then in carbon-13, 13 would be the mass. And you just find the percentage average. We will do a example. An example. Lithium is made up of two existing isotopes, lithium-6 and lithium-7. Lithium-7 has a mass of 7.015 U and accounts for 92.58%. Lithium-6 has a mass of 6.015 U and accounts for 7.42%. So let's do the math on this. So we know we're going to have to state that sample is out of 100. 100 grams. So the sample is out of 100 grams. But now we got to write our little equation. And how we do this is you grab, so let's say we'll grab lithium-7. You put the atomic mass, which is 7.015, and then you're going to multiply it by the decimal form of 92.58, which is 9.9258. And then you're going to add it. Lithium-6 has an atomic mass of 6.015. And we're going to multiply that by the decimal form, which is 0.0742. So if you do the calculations on this, you can do that really quick if you want to see if you get the right answer. I'm going to say the answer in 3, 2, 1. It's going to be 6.94 U. Don't forget your units. Okay, don't forget your units because that's very important. I also realized it is sideways. The general formula for average atomic mass is average atomic mass equals percentage abundance of isotope 1, which is in decimal form, don't forget that, times mass of isotope 1 plus percentage of isotope 2, which is in decimal form, times mass of isotope 2 plus etc. And you can keep doing this on and on and on. So yeah, if you found this video today helpful, I'm glad I could help you out. If you didn't and it made you more confused, I'm really sorry. There's many internet videos. Oh my god, that makes me sound old. There are many YouTube videos. Yes, I'm not that old, okay? I'm still in high school. Yeah, I don't think anyone's gonna watch this, not gonna lie. Except my best friend that needed my help. So I'm doing this for her, and that's all that counts. So see you later, and this is Lilia, Learning with Lilia. Yeah.